Okay, we're moving on to section 2 of chapter 14. And next we're going to take a look at surface area of different types of circular solids. So we're going to take a look at cylinders, cones, and spheres, and then we're going to take a look at a subset of cones. So let's, I could give you the formulas for these, but I'm going to derive a couple of them, and then we'll move and try some example problems from there. So we're going to look at the surface area of a cylinder. A cylinder consists of two bases, and what's left over is the lateral area. The lateral area, if we peel it off, sort of like the label of a can, and we slowly unravel it so that it turns into a rectangle. So we can find that lateral area by finding the area of this rectangle. There's the length and the height or width. The length is just going to be found by the circumference of the base of the cylinder, and the height is just going to be the height of the cylinder. So if you label the cylinder with height and with the radius, the length, the height's going to be the height, and the length is just going to be 2 pi r, or the circumference of the cylinder, of the base. The next surface area we're going to find is the surface area for a cone. If we start with the sector of a circle and we bring the corners of the sector together, you can see how it forms a cone. Now, to find the total surface area of a cone, you're going to need two parts. You're going to have the lateral area, and you're going to have the base, the bottom of the cone. The base should be easy. That's just finding the area of the circle. And the lateral area is what we're going to try to find right now. It's the lateral surface area. Now, if you think of the lateral surface area, once again, if you remember where we got it from the sector. So if we unravel it again, and we put it back into the original sector that it came from, now the slant height is basically the radius of that sector. And you can see that the length of the arc is just 2 pi r. And so if I want to find the area of that sector, it's going to be the fraction of the area of the length of the sector divided by the circumference of the circle times the area of the circle. And if I simplify that, I'm going to get pi rl. And that's how I get the lateral surface area of a cone. The formula is pi rl. Okay, I know I went through that really fast, but just to quickly summarize, because this is the important information really. There's a cylinder. To find the lateral surface area for a cylinder, you would just do the circumference times the height, or it's going to be 2 pi r times the height, where this is the radius and this is our height. And the circumference is what we're talking about, is the circumference of the base. The total surface area will just be the lateral surface area plus two times the area of the base. The next shape that we talked about, and I kind of went through super fast, was the cone. The lateral area for a cone is just going to be pi times r times L. It can also be found using 1/2 of the circumference times the slant height. Okay, so either of those formulas work. I like to remember this one by saying Pearl. And then the total surface area will just be the lateral area plus the area of just one base, since this one only has one base. The third type of figure that we're doing in this section is just a sphere. Now the derivation for this one is really complicated. Well, it uses math that you guys don't know right now. And so I'm just going to give you the formula. The total surface area for a sphere is just 4 pi r squared, where the radius is simply the radius from the center of the sphere to any point along any part of the sphere. And that point, of course, that radius will stay the same throughout the entire sphere. Okay, so let's jump to the next page and let's try a few of the problems. Okay, so we're going to do the first problem on the second page here. The first problem here is that it gives you that you have a diameter of 6. So that means, of course, that the radius here is 3. The total height is 17, and the slant height is 5. So you have a figure here like this. And so this height has to be 3 here. And this is going to be 3 also, right, for the radius. If this slant height here is 5, then the height of the cone, it's just going to be a 3, 4, 5 right triangle, is going to be 4. And so this middle section is going to have a height of 10. And now that we've done that work, we are ready to go ahead and start plugging it into some formulas here. So for the cone, we know that the surface area, we're going to be looking at just the lateral area here. And we'll talk about why. We're not going to talk about the base. But for the cone, it's just going to be pi RL. Okay, and the radius is going to be 3. The slant height is 5, so we're looking at 15 pi is the lateral area for the cone. Now if you notice, we didn't include this base here because for that particular solid, you can't actually touch that portion of the base. You can't touch that portion of that solid. So we are not going to find the surface area of that base. And likewise, when we're doing the cylinder next, we don't need to include either of those bases since we can't touch either of those bases either. So let's take a look at the cylinder, which we're going to find the lateral area for. And we know that for a cylinder is just going to be the circumference times the height, or 2 pi r times the height. Radius is still 3, so it's going to be 6 pi times the height, which is 10. So it's just going to be 60 times pi. And we're going to leave it like in that type of form, 60 pi and 15 pi in exact form, because it's exact. And so the next thing we'll look at here is a sphere. And actually we're looking at half of a sphere, or a hemisphere. And so it's going to be the lateral, well, just the surface area is going to be 1/2 of 4 pi r squared, or half of the surface area of a sphere. And so we get 1/2 of 4 pi, and again the radius is 3, so it's 9, and so it's just going to simplify to 18 pi. And if we add all these together, we will get a total surface area of 93 pi. And that's it. So that's what we're going to be doing in this section. There's obviously going to be some more difficult problems. If you try some of the problems down below, you'll get an idea of the type of word problems we're going to be doing with these type of surface areas of cylindrical and cone and sphere type figures. We're going to move on to the next page, and we're going to take a look at a special case here of a cone. So a special type of solid that's related to cones is called a frustum. And a frustum looks like this. It basically looks like a cone where the top's been chopped off. And so when we approach these, as far as finding the surface area, we will follow a strategy. The first part of it is to go ahead and extend the frustum until it looks like a cone again. So I'm going to go ahead and draw something like this and like this, and it's going to look like a cone. The second part is to find the lateral area of the entire cone. And then what I'm going to do is I'm going to find the lateral area of this part of the cone. So find the lateral area of the smaller cone. And then I'm simply going to subtract. I'm going to subtract that smaller cone from the lateral area of the entire cone. And then I'm going to add, don't forget, I have to add my base. And I'm going to end up with two bases because I'm going to have a base here and I'm going to have a base here. Remember, the original shape for a frustum was that figure right there. Looks like a lampshade. Okay, so let's try an actual problem down here. So you have a frustum, and the bottom radius is 6, and the upper radius is 3. And the angle between the bottom radius and the slant height is going to be 60 degrees. So that angle right there is going to be 60. So we're just going to follow the procedure. I'm going to extend these two slant heights so that it turns it into one gigantic cone. And then I'm going to go ahead and do some work here to get some different parts of this. I know that this is going to be a 30, 60, 90 triangle. The entire triangle is going to be a 30, 60, 90 triangle. So I know that this portion right here is going to be 12. And I can also see here that I have similar triangles. I have a triangle here, and I have the entire triangle all the way like this. So my blue triangle and my orange triangle, they are similar to each other. And I know that this part and this part are in the ratio 1 to 2. So that means that this has to be in that same ratio. This is going to be 6, and the entire slant height is going to be 12. So this is also going to be 6 right there. And if I wanted to, I can go ahead and set up proportions and find those lengths. And I think those are the pieces that I need to go ahead and find the various lateral areas. So in my step 2, that's my step 1, extending the lines and kind of finding some of the information that I need. My step 2 is to find the lateral area of the entire figure. So it's going to be 1/2 of 12 pi times the slant height, which is 12. And that's going to be equal to 72 pi. And then the second one here is 1/2. This is going to be for finding the upper one. 1/2 of 6 pi, which is the circumference, times the slant height. So I'm using the other formula, not the Pearl formula, the other one, is equal to 18 pi. And I'm just going to take those two and I'm going to subtract. Remember, I used the formula that was the 1/2 circumference times the slant height, by the way. And then if I go ahead and subtract those, I'm going to end up with a lateral area of 72 pi minus 18 pi, which gives me 54 pi. That's going to be my lateral area of the frustum. And then the last thing I'm going to do is find the area of the two bases. The two bases are going to be 9 pi and 36 pi. And then I'm just going to add that with this guy right there. And so my total surface area is going to be equal to 99 pi. All right, so I'm going to stop here and let you go ahead and try some problems from the book. And good luck with them.